So what is computational design? In very broad terms, it is just an algorithm. We already do it on a daily basis. How far have we taken it? Question here. It comes into three broad forms where parametrics. You have parameters, and that's what Dynamo is doing. You have parameters, you change those parameters, and then using those parameters, you have an algorithm, and that algorithm develops the solution. And then you go and think about how can we use that algorithm and that parametric solution to develop the generative design. So computational design, as we do today. So I've been a structural engineer, so I would just bring out a structural analysis model which does computation. You set up its parameters, you set up a model, you give it input, it does a calculation which you don't see, but you have to understand what it does, so it gives you an answer. So you have a visual model of whatever you're looking for, in this case displacement. um, and this is what we do with it right now, and we're trying to move away from that towards trying to enable the modeling side of it, for the 3D modeling side of it, to be more a computational solution. So these are things which I've done in the past. So this is done in 2019 when I worked in Hong Kong for WSP. This is a software package which I'll explain a little bit later. But similarly, like Dynamo, it has a number of parameters. It allows you to change a number of things. For in this case, it's a building. It's a 150-meter tall building, which we are looking at multiple solutions. The architect was always changing their solution and the layout, and they would pass this new layout, and they were working in CAD. They were not working in 3D environment at the time. So I didn't want to do 5 sets of analysis and take 3 weeks to do that. I did once, and then I stopped doing it, and then I went and took I think 2 days to go and develop this script so that it would model the whole thing for me. So I would just model my stories very quickly, effectively. It's very technically complicated from the modeling point of view because it's not a repeated solution per se. And once I'm happy with the solution, or once I want to analyze the solution, which is improving my understanding of structural analysis in terms of, in this case, wind loading, which is determining the design, this modular design per se. And this is the software ETABS, which is used for structural analysis in the buildings design department. And the software helped me to model this very quickly, instantly, to an analytical software. I analyze the software, and the whole thing gets developed based on what I have, and then the core structure has to be separated. And this was the time where there was no API. There is an API for ETABS, but there is no direct connector to say you can automatically. So there was some bit of coding I had to do to make this connection work through the help of a lot of people in the community at the time. And then the same approach when I moved over to the infrastructure team, when I worked for bridges, I went and looked at, because there's a lot of feasibility analysis happening, the same software application enabled me to do sketching, and I wouldn't do sketching in 2 dimensions. I like 3 dimensions, and then I could put it in context, in a place, in a real situation on Google Earth to show what that looks like. And then I would sit with my stakeholders, have the discussion, and then I would go ahead and then model it. Here I'm modeling a truss based on the requirements with those 2 white points. I just write points, and those 2 points determine the length of the bridge, the width of the bridge. All these are parametric at that point because we were deciding what is ideal, what are the requirements of DMRB, and then once we all agreed on the solution, then it was connected to LUSAS, which this had a connector in between, which I'll explain a bit later. And this does the same thing. It lets you analyze. It's just saying that it's very interoperable. It's helping you model things very quickly. And then generative, when you come to look at it, you start looking at how do we generate the whole thing. So we know the parameters. We are a designer. We know the code. We know what are the requirements from the code. Can we automate this? Can we look at what does that mean? So, for example, in this image over here, it is a bridge which has a instruction set which will say you got start point and end point. You got A, B. You can't see the B, so B is there, C is there. Draw me a bridge. Follow this curve. These are the at A, B, and C. I will have I will have a column or a pier. I will have cables. I have this many number of cables. Build me a bridge. So in a meeting, I could sit with the client and move these 3 points, and it would behave. And the cables would move from left to right if this point was moved to that side. So it was very interactive to see, because we're trying to find the best alignment. And then just keep pushing. Then I became a lead on an underground track crossing for passing cables under the track on HS2. It became a standard design. So when you have a standard design, you want to make it a modular design. When you have a modular, you have to identify what drives the design. The design was cable bending radius. So high voltage cables have a radius which is 1600 per se. Low voltage cables have 500. So and you're supposed to put this inside the ground. It has to go under the track. It has to fit. What is the smallest size you can do? And at the time in the 3D solution, MicroStation and AutoCAD could not do a 2D plan to identify the 3 or 4 degrees of bending for a pipe. But I was simple enough to use a function called fillet in Rhino, and then I could just have a solution, and I could say this fits. I could show this to the client. They would assess if it would fit, and if they're all happy, this would be the size we would use for the whole project. So this became a way of standardization, and this is like improving my technical capability as an engineer to get the best solution, rather than just building out a tool per se. So how did I do all of this? I used Rhinoceros 3D. This is simply because I'm familiar with this from buildings design, and it was more of a open community. You would meet different kinds of people, like hobbyists. You've got people from university. You've got people with PhDs experimenting. You've got architects on one side. So this is what it looks like. The interface is similar to AutoCAD or many similar modeling software. It has layers. It's got some 3D visuals. You can do 2D and views. This is the old version. I know it looks a little more better. It's got dark mode. If that finds you fancy. And Grasshopper is like Dynamo. It is I would say the subset of Rhino. It does similar things. It would give you shapes because you want your shape within Rhino to be parametric, means live. It would create a live solution, and you could actively, as you said, this is the Rhino workspace, and this is your the Grasshopper workspace. So you actively change your solution as you move your parameters. And because this is explained, I won't go into detail. It does almost the same thing. It's just that you will find a lot more interoperability opportunities in this situation. So what does that look like? Let me see. So this could do structural analysis within the software itself. So there's a plugin called Karamba 3D, which I've used for preliminary design. It can do a number of analysis. So you draw out your model using your scripts per se, with components and nodes, and then you run an analysis, and it will tell you what kind of behavior the structure is doing, and then you can actively change the size of the structural element or whatever it is, and it will tell you the analysis will change. So what is Karamba? So a couple of solutions that come into here. It has got a truss. You can simply serve endpoints. You get the behavior. You can do a moving load analysis at the same time. Then you can expand your reach if it's a deck, and then you will get bending moment, shear forces, active, and it's all active. You don't click a run. You actively change. So as you move your model up and down, the analysis is changing. So that helps you. That helps me, and always helped me make a better engineering judgment there. Yeah, and this last bit it is showing is something called as generative design. The parameters here that is a slab on top, and the 3 are the support columns or walls. It is finding the best position to identify what is the best arrangement for that structure. That uses a solver. It helps you to generate your solution. If you know all the parameters to generate, give me a solution. So you can do a number of solutions in that aspect. So this is where this grasshopper rhinoceros gets interesting, where you have interoperability. Autodesk has in 2022 they started connecting this to Rhino, and in 2023 they connected this to a grasshopper. The behavior is a little bit different. That I'll explain a little bit. But these are the way they've looked at this is they've gone to ACC Cloud. That is where the exchange is happening, and because of that exchange is happening there, they can connect it into Revit, CAD, Civil 3D, Venture. So it's just opening it up a little bit better. So this is what in 2022 they achieved in the Rhino connector. So this is basically Revit now. It is a Revit model, but there is surface model. There are so many elements going there. Say, for example, you want to integrate a specific element of it, you will send only that much. Simply because the workflow is changing from the engineer or the designer may use Grasshopper or Rhino over Revit or Civil 3D. It's just a matter of what the existing workflow is and how your workflow will be in the future. How will you communicate to your BIM team in the future? So that's what this connection is like, and that is the very purpose of having this. So once you have an exchange, it is to have the data exchange. You will download the product that is coming. It's all live links, and then you choose your elements if you want to modify it manually, if you want to sketch it differently, if you find Revit is a bit daunting in terms of sketching, because or if you find that you are happy with looking at this in a different way, whether you want to do an analysis or if you want to do the sun shading with the Ladybug tool, which is also possible here. So, and then once you have made those changes, you can always bring it back here, and that's the benefit of an exchange, because it fixates on the start and end point. So if you were to bring a new element into this, designed an element, you want to bring it back into your model. Now you're using this as a deliverable because you'll cut a section here, and then you'll get that segment in your drawing directly without having to manually model any of that.
Automate your information exchange processes between Rhino, Revit, and downstream apps with the new Dynamo and Grasshopper Data Exchange connector. A Revit architect uses the Dynamo connector package to filter and send a surface geometry into Autodesk docs. The exchange isolates the data relevant to the designer instead of sending the entire model. A designer exploring design options in Grasshopper uses the Data Exchange connector plugin to preview just the shared data from Revit and consume it through his Visual Script graph. Leveraging the Grasshopper script, the proposed surface is rationalized into a randomized dynamic triangular facade. The Grasshopper connector includes a component to send information about the facade back to Dynamo, Revit, or other apps. Back in Revit, the Dynamo connector brings the rationalized points of the panels as easily reconfigured native Revit adaptive components. Updates made upstream in Grasshopper flow seamlessly through the same exchange to Dynamo and Revit. Streamline your automation workflows between Revit, Rhino, and downstream apps with the Dynamo and Grasshopper Data Exchange connectors.
So if you had a complete structure and you want a single element to be checked again because you changed the design, this is why Grasshopper would be very relevant, because you would use Grasshopper to develop that. Do your analysis, you'll push it to Autodesk into a component, because the whole element could be realigned, moved anywhere. So you want that in a component so that it moves together in 3D space. So this is why you would want to do the Grasshopper connection rather than the Rhino connection, because Rhino is still a static model, same as what the Civil 3D is without the Dynamo. This becomes a static model. So that's what Autodesk had. And Autodesk only went and built it in 2022, 2023. This is after people requesting, and then other people developing. There being competition, and then the reason for that is simply because there are better things out there, and they're very well connected. There's a lot of open source or bigger communities that are helping towards developing more solutions. So Speckle is a platform where you have this interconnectivity. It was founded by an accident, as the founder says. He used to work for Arup, and then he realized that this becomes a platform that more than Arup can benefit, and then he went and started up his own thing, and then Speckle became a place where everybody started contributing. We want to connect to this common data platform so that we can connect with either Rhino, Dynamo, Sil30, anything. Try to do everything and anything, because in the end we want to communicate better. That's the goal here. So what is Speckle?
Send and receive your digital data with Speckle, a modern platform built for the architecture, engineering, and construction industries.
Speckle isn't constrained by proprietary software, file formats, and difficult APIs. It's a single solution for interoperability that enables seamless collaboration among interdisciplinary teams.
We're bringing object-level version control to the design process, putting you in charge of your data. Curate your project changes while staying up to date with real-time notifications, and visualize your models on the go from any browser or mobile device.
Or dive deep with our developer-friendly APIs and SDKs. We're Speckle, we're open source, empowering you to build the next generation of apps, tools, and workflows for AEC.
And these are what it connects to. This is what I could just quickly get from the internet. Connects to Excel, ETABS, QGIS, Blender, Bridge, ASWorks, Advanced. So it could connect to anything because the API is open, as long as there's an API of any software that exists, and there is either a hobbyist out there sitting in programming to make the connection, or whether the developer actively, like for Autodesk, they actively develop Speckle connectors, then you will have a connection. So they're being collaborative. Very important thing to be collaborative here. So that was Speckle again. So BOEM is something which I used in 2019 and for my solutions. This was an initiative by the company called Bureau Happold. And they approached the same problem with the same similar solution. They had ended up developing the BOEM tool. It is a big, massive tool which enables you to create all these connections, and you can go as deep as you want, just like Speckle. But Speckle became more user-friendly because they're hosting their data on a platform, where BOEM, as you install a plugin and it forms part of a Grasshopper plugin. Same for Excel, same for all these software. You have to install a small plugin. And then you don't have this common cloud system. You have just live interconnectivity. In Speckle, you have to, you're pushing everything to one central location, and from that location, you're taking it to each place as you want it. So you will have, say, a bit more control in terms of version control, but in terms of those kind of aspects of your modeling, you may not get that unless you have, inbuilt it within your workflows. So you don't have to do all of that if you use Speckle. So it's more user-friendly, I would say. But that didn't exist when I was starting to do this. So this is what I had. And then I just used the very basic stuff when it came to, an ETABS connector, a LUSAS connector, a MIDAS connector, all the things that I used for my structural engineering. And the only thing was I used to export my models in DXF or TWG to the CAD model, and they could model it out very quickly because they have sufficient dimensions to work with, rather than starting off from scratch with sketches and all that. So in 2019, I guess it was that was the case. So I just end with this. This is my last slide. It's a bit of a rebellious way of saying, are we welcome to do computational design? Okay, there are a number of issues which I've put as bullet points. These are the problems that exist. A significant one being as a challenge which I've faced is skill gap and cost. Because we want to learn, we can't learn because we don't have time. And if you want to learn something, it costs towards either project cost or development cost. It takes time, and we don't. And because we don't have that, we don't have the capability to do these things or to become more friendly with these things. So this is the ideal experience of workflow which I have, and which many I share with many people, that we will see cool things, we will get inspired, and then we will end up learning it. And then we see a couple of videos and go, oh my god, this is way too much. And then you'll start, okay, let me do a project. It's a good way to develop this, to develop learning. And then you will stop simply because you can't finish it for some reason. Again, if it was a project for a live project which you're doing, then you have to deliver it, so you have to finish it. Or you may somewhere in the process stop because you can't finish it. You may go back to your existing workflow and finish the project because you want to finish the project. Deadlines are you have hard deadlines you can't meet, so you just go to 2D CAD and get it done, or whatever that may be. And then again you have this new motive. So this constant cycle is what has helped myself and those who are in striving for this to develop solutions. So it's been helpful, but I think as I have progressed in my career, I've started to understand that I have to be more empathetic to understand that these are the pain points. And because of these pain points, to encourage growth or diversity of everybody trying to learn what is low code and no code and digital and all that, we have to understand that they need more time. We need more development time. We can't tell you it will happen in 10 hours. We could if we knew what we were doing. So if we knew what we were doing completely, then yes, we could definitely tell you, but then we need development time. So there is a certain amount of risk we take, and because of that risk, we are ready for the challenge. We fail. Because we fail, we learn something and we try to do it again. And this has to be encouraged. Then only we can have. That's what I think. We can have computational design as a business as usual. The aspiration to achieve that.